All right, thank you. So in the webinar today, I'm going to move away from the comfort of slides and move into the domain of live coding. Fortunately, we all know very well that if you do something live, things will go wrong. So let's see what goes wrong, and let's give it a go. There's a few things that we're going to be doing today. First of all is I'm going to show you how you can define what we call the core API, which is basically the combination of commands and events. Of course, if you've been using Axon 2, there's not much of a difference, but I'm going to throw in a bit of Kotlin in the mix to show you how the Kotlin language can be used to make it a bit easier. Then we're going to implement given, when, then test cases. We're going to do that in plain Java, so don't worry that this is a sort of a Kotlin workshop. Then we are of course also going to implement the aggregate itself, and that is very comparable to how it's done in Axon 2. There's a few little differences that we'll have a look at as well. And something that is really new in the Axon 3, it's available in milestone 4, which was released yesterday, is the configuration API, and it allows us to set up the runtime components much more easily compared to what you're used to with Axon 2. So just to make sure that we're on the same page with regards to functionality, today we're going to build a banking application. And if there are any bankers listening or watching, don't even assume anything that I don't know anything about banking, so except that there's accounts and then you can put money on that account and you can take it off. That's more or less what I know, and that's also what we're going to implement. So there's this concept of a bank account. We can create one, and then we can withdraw money and we can deposit money, and there is the concept of overdraft as well. So we can define the limit, the amount of money that we can take off the account without the money being on the account actually. So let's give that a go. What I've done already is I've set up a little application. I went to start.spring.io, and I have set up and configured an application here. Of course, there's the group ID and the artifact that you can choose, a little description, the package name, which is the default value provided by the Spring initializer, and I've selected a number of dependency. In this case, I've selected web. We're not going to do anything webby in this session. However, in a future session, we will be adding web functionality. We need a database, and the easiest one to use is HSQLDB, JPA, and there's a framework called Lombok that we will be using as well. We'll show you why during the coding session. Now, unfortunately, there is no Axon dependency here, so if we go to our banking application, we have to add the dependency for Axon by hand. Axon test. So we're going to add the milestone 4 dependency on scope test, and then of course the regular dependency. We're going to add the Axon Spring dependency. It will transitively receive the Axon core as well. Not all my examples are going to be Spring examples, but at least now I've got both on my class path. So far so good. So right now I can go to my application. This is a very, well, basically this is an application that will run if you press run. It's compiling. And of course it will do absolutely nothing. It will just sit and wait for user requests coming in to serve out a little 404. At least we know it's running, so that's good. So far so good. first thing we need to do is define this this core API. So in our banking application, we have the concept of an account. So let's create a little module called core API, or module, sorry, package. And we're going to create a Kotlin file, and we're going to call it account API. Now, of course, I haven't done anything yet to the project, so IntelliJ says Kotlin is not configured. I can say I want to configure it for all modules, all right. And it will add some Maven dependencies and everything to my project. And that's about it. And right now, I can use Kotlin, which basically just compiles to Java classes, except that I do not need to write all the classes myself. So right now, what I can do is say I've got a class. And let's say we do create account command, and it has a few properties. It has a property account ID of type string, and it has a property of overdraft limit of type int. That's it. So this is all we need to define a command. We said we could withdraw money as well, so we can do withdraw money, and of course we need to mention the account ID as well, and we need to define the amount we want to withdraw. When we create an account, we have the account created command. Overdraft. The auto-completion already sees the properties that you've defined, so I can quickly select both the property and the type for my commands. Withdrawn, account ID, and amount. And just for complexity's sake, we're going to add as well the balance of the account. And that's the balance the account had after the money had been withdrawn. So this is the basic API. Notice a little typo here. Let's add some suffixes. Draw many commands, so we don't get confused about what is a command and what's an event. All right, that's pretty easy so far. Right now, let's create a little account aggregate. Account. Now in Axon 2 we needed to extend the abstract annotated aggregate root. Right now we don't need any of that. Of course we need a little more than what we have right here, but we'll get that there later. Right now all we need is the core API and the aggregate. So let's create a test case. Let's define what the aggregate needs to do before we start building what it should do. And we create a little test case. I'm using JUnit 4, and what we need to do is create a fixture for the account. Oops. Like so. That's basically all we need to do. And now we can create a test case. We can say we want test account. Sorry, create account. Very simple test case. Fixture given no prior activity when new create account command. And notice how I can just use the Kotlin classes from my Java classes without any weird parameter types or anything. So the account ID, let's assume 1234, and an overdraft of 1000. And then we expect an event of type account created event with 1234 and the overdraft limit. Now of course we can run this. And I said things would go wrong, but this was kind of expected. So there's no handler for this command, which makes perfect sense because the entire account is empty. So let's implement this this feature. And what we can do is we have the @command handler public. Let's make it void. No, sorry. It's a constructor, and we pass in the create account command as a parameter. And when that happens, we apply an event new account created event. And we pass the parameters of the command into the event. Now, the apply method doesn't exist on this class anymore. In Axon 2, the apply method was part of the abstract annotated aggregate roots. Right now, what we can do instead is a static import. So we can just statically import this, which makes it also very easy to transition from an Axon 2 codebase to Axon 3. You just remove the imports and you fix whatever errors that you have in your handler. Now, we need a bit of state here. If I run this, it's not going to work yet. Because there is no R constructor. Now, personally, I don't really like no R constructors, so what I'm going to do, and this is where Lombok comes in, I'm going to define a no args constructor using the Lombok annotation, and it will generate it for me either at compile time if you have the plugins or at runtime. And now it will still complain about something, and it's complaining, as you can see here, about the aggregate identifier being unavailable. It's a null value because we haven't defined one yet. So let's create one private string account ID. And since this identifier is part of the aggregate state, we need to update the identifier based on an incoming event. Like so. So right now, when we create a command, it will apply the event. Applying the event will trigger this method, which will set the account ID. And in that case, Axon will know what the aggregate identifier for these events is. And now if we run this, we get a green bar. So that's our first test case. We haven't seen the fun part yet. So this is just creating an account. Right now, we want to see what happens when we withdraw money. So let's test withdraw reasonable amount. What's reasonable? I don't know. Let's see. Depends if you ask me or ask Eliska. So we'll have the Eliska test case later. Given the account was created, event with 1,000 of overdraft limit, when we have a withdraw money command for that account of, let's say, half, we expect a new money withdrawal of 500, and if you're good at math, you'll know that there's 500 left, which makes it not a very funny use case. So let's withdraw a bit of it. We might mess up numbers and still get it right. See, I'm messing up already. 600 there, 400 there. So we withdraw 400, and we will have, we withdraw 600, and we'll have 400 left. And of course, there's no command handler for this. And you might think, oh, this is just because you're doing a webinar, but this is always the way I code. I just write my test cases. This is what I should do, and then I just run it. And oh, there's a handler missing, or there's an if statement missing. I really don't care about any functionality unless I've got a test case for it that shows that the aggregate can actually do that. So we've got we need a command handler here for the withdraw money command, and we're going to apply that, and now we want to apply a new money withdrawn event command. Well, I can use the account ID directly, it's the same anyway. And we know the amount, that's from the command. However, we don't know the balance. So we need to store the balance somewhere and deduct the amount from that. Notice that I'm actually not deducting the money from the balance here. I'm just saying what the balance should be when applying this command, because I should not do a state change here. So if I have my balance, I should not update it here. I should not say balance equals balance minus command get amount. Right. Event sourcing handler, of course, we need to change the balance when money is withdrawn. And now the advantage that we have it in the event is that we can assign it directly if we did calculations correct. And we didn't. There's something wrong, and I know what it is. It is the identification of the target aggregate. So Axon at this point doesn't know when we want to send a withdraw money command to what aggregate it should be routed, because we didn't specify any of the identifiers. Axon doesn't see that the account ID is actually the identifier you want to use, so we need to tell him that. And we specify that by putting an annotation on the field, in this case, of the account ID. Now if we run it again, Axon will know how to route the instance. And oh, what did I say about getting the balance wrong? Amount and balance, so test case is all right. I'm deducting the amount. This is where it gets annoying. Ah, that makes sense. Test case is wrong. Actually, because if you look carefully, got minus 600. I'm deducting 600 from 0 and not from 1,000. So I've got minus 600 euros or whatever, dollars. Because I didn't put my account to 1,000. It just gives me a room to go up to minus 1,000 to spend money. All right, now let's assume someone else is using the credit card and they're attempting something else and they want to withdraw 1,001. We expect no events. And we expect an exception of type overdraft limit exceeded. Exception, which we did not specify yet, so we're going to create that class. Extends, let's do exception. Right, let's keep it simple. That's it. Sorry. Let's run the test case and see what happens. It's failing because it expected nothing, but it got a money withdrawn event, and that's because we didn't do the overdraft checking yet. So let's do that. We need an if statement here. If the balance is larger or equal than what we want to withdraw, but that doesn't take the overdraft limit into account. So we need that as well, and we need to create a field for it. Of course, if we have a field, we need to update its state, and that state is currently only set in the creation event. So we set the limit to event.overdraft. Else throw new overdraft limit exceeded exception, which needs to be declared. Fine. Right. So I'm checking whether the balance plus what we can overdraw is at least equal to the amount that we're trying to withdraw. And if that's the case, then we're fine. We're going to withdraw it. If it's not, we throw an exception. And the tests are green as well. So far, it's all good. Now, there's always a nice test case where I like to try to deduct money twice. So I test withdraw twice, because you want to be really sure that it's using the past events as well. So given I've created the account, with 1,000 and I have withdrawn money from that same account, let's say 999. I could do something weird and say I've got 100 left, but that's not. When I withdraw some more, 2, I still expect the overdraft exceeded exception. And it says here, but returned with null. So it says here, if I've created an account and withdrawn, no, of course I did the same mistake again. So I've withdrawn money and I said the balance became 1. We simply look at the balance. So imagine in the history of the bank, there has been a calculation mistake and somebody has been given a balance that doesn't match with the amount withdrawn. Then you can see people can withdraw money, because that's what we're actually using to the value that's here is being used to set the current balance. Of course, that was incorrect to say that's €1 left. So we run it again. Right. So as usual, the bugs are in the test cases and not in the implementation. Anyway. So far, so good. So this is pretty simple. It's in a very similar to what we've seen in Axon 2, except that we did not need to extend from anything. You can easily use Lombok to create the no-args constructor that you're required to provide. And for the rest, it's really the same. It's a static import for the apply method, but other than that, nothing really changed in the aggregate structure. Now, it does get more interesting if we want to run this. So let's create a little application class. I'm not using the Axon Bank application that's already there. That's a Spring Boot application. I'll go to that one next. And let's create a main method that allows us to run this. So right now we're running the account in a test setup. That's pretty easy. It's one line of code. Tell the fixture to set up a test environment and send some commands and receive some events. So right now what we're going to do is set up a runtime environment, one that we can use for real. And in Axon 2, you needed to specify a command bus, event store, define the aggregate annotation, command handler, adapter, etc., etc. Right now we can use the new configuration API, configuration, the Axon framework one. Of course, every framework has a configuration API, and I can use the default configurer dot. Default configuration, and now I can just say I want to register an aggregate. So I configure the aggregate account dot class. That's it, because that's all we've got right now. And this is going to give me an entire infrastructure with command bus, event bus, but not event store actually. So in Axon 3 there's no command bus and event store. If you have an event store, it will replace the event bus. So the event store is the primary means of communicating events between components. So we need to configure, for example, the embedded event store, and I'm going to use the in-memory storage engine. Now what I'm passing here is a little lambda expression because I'm not providing the instance that of the in-memory event storage engine that the application should use. I'm providing a function that, given the configuration currently available, what should the in-memory storage engine look like. So if I need anything in here, doesn't have any parameters, I can use C dot and I can get the components that I need to configure this component, so I can have dependencies between components. Now I need to start that configuration, and now I can do config.command-bus. So I can get the command bus from this configuration, and I can send a command. I can say new as command message new create account. Let's do something different. I use a static import for this one. So I can create an account, and then I can do config.command-bus.dispatch as command message new withdraw money command. And from that same aggregate, I'm going to withdraw 250, whatever. And then I can run this. And there's a lot of logging because I've got the Spring Boot application, and it sets up logging well, with a lot of debug statements. However, what you can see here, it says command executed successfully withdraw money command. And if we move up a bit, it says command executed successfully create account command. That's because the default callback is just one that logs the command result. Of course, we can try to break things. So let's withdraw 251, which should cause the account to become overdrawn too much, and we get this exception: overdraft limit exceeded exception. So this is exactly what we expect. Now, this configuration API allows us to configure a different command bus, for example, as well. So based on the configuration, we want a new asynchronous command bus. Fine, we can run that as well. And we should be seeing these logging statements from a different thread. So we can see now that these commands are being executed by a different thread. In a thread pool that's actually been created by the bus itself. So as you can see, the configuration API allows us to easily change the implementation that we want to use in our application. And for everything that you do not specify, you get a sensible default. For example, simple command bus, embedded event store, etc. So let's do the same in Spring and see how that compares. So in Spring, we don't need to use the configuration. We don't need to use this configurer. All we need to do is say we want to enable Axon auto configuration, And this will give us command bus, event bus in this case, for our application. Now, we don't want an event bus, we want an event store, so we have to give Axon a few hints about what we expect. And we can do an event storage engine. So we can provide an event storage engine and say we want a memory event storage engine. Now, because there's an event storage engine Spring Bean, Axon will see that you have the intent to use an event store. Now, this annotation will also do class path scanning, and it will check for any aggregates on the class path. However, we haven't done something on the aggregate yet that allows Spring to recognize it as such. So in the Spring module, there's an annotation for a stereotype annotation for aggregates. So you can define the fact that this component is an aggregate. And as you'll see, it's just a Spring component with the prototype scope, which means there's not one instance, but there's multiple instances, different instances of the of this implementation. So right now, this is all we need to do to tell Spring that we've got an aggregate. So it's picked up as part of component scanning, and we've told Spring that, well, through Spring, we've told Axon that we want to use an event store and store these events in an in-memory storage engine. Now, of course, if we run this application, nothing will really happen. So we should be able to auto-wire. No, that doesn't work. Configuration. Of course, this is not something you would do on a production system, but we can get the bean of command bus. So we're getting the command bus from the application context, and then we can, well, let me be a lazy developer. Oops. Let me copy and paste that. So we're doing exactly the same as in the other case. We're taking the command bus and we're dispatching a number of events. Of course, we expect exactly the same outcome. Let's see if that's the case. Of course, the startup time is a bit slower because we've included, or I have included, Hibernate, which I'm not using yet, but it's doing some scanning, and that takes time. So we can see here, command executed successfully, and command resulted in an exception, and everything in the main thread. So in the other configuration, you saw how we configured a, let's say, non-default command bus implementation. And we can do exactly the same here simply by providing a bean. The name doesn't really matter. And we can say we want to return a new asynchronous command bus. That's it. And if we run it now, we should be seeing that the thread on which the outcome is reported is a different one. Fingers crossed. Of course, I'm sending everything asynchronously, so probably they're overtaking each other. However, a command resulted in an exception. The aggregate was not found. And that's because the creation command was actually executed last, and that one succeeded. That's the disadvantage of having the async command bus. You don't really have influence on the order of things. But we can solve that by creating a command callback, and we can say on success, oops, dispatch those don't need to do anything here. And this is due to the implementation details of the asynchronous command bus. If you use the disruptor command bus, it will asynchronously execute the commands, but it will always do that in the order that you've provided supplied the commands in. And right now you can see that I've executed one command successfully, and the next one failed. And where is the third one? That's nice. This is withdraw money, so probably we've got one. Yeah, we're not logging that because we're supplying our own callback and not the default, so it's not being logged. And if you don't believe me, we can do a small system out. See, told you. If you don't take this personally, if you did believe me, but if you didn't, this is for you. Right. So far so good. So basically this is our little application. I hope I've convinced you of the fact that with the new configuration API it's much easier to get started. All these default components that you needed to define, they're already available. If you stick to standards, then there's not much configuration to do. You just need to mention the fact that you want to use an aggregate or a specific event storage implementation. And of course, there's a lot of customization that you can do. So in here, you can specify the name of the repository that you wish to use. If you do not want Axon to automatically create one for you, which is very useful if you don't want to use event sourcing, for example, for a specific aggregate. So just imagine you want to use a JPA account repository for this. Repository. So we can define a bean. I'm not going to completely configure that. Public repository for account JPA. So this is the name that we've supplied up there, and we return new JPA, generic JPA for the account class, and we are going to use the event bus and of course the entity manager provider is a bean that we need to supply as well. Entity manager provider, return new container managed. So this is stuff that we are working on automating as well, which is the configuration auto detection. So we automatically detect JPA on the class path. So we assume that you will want to use the JPA entity manager provider, so that those things are automatic as well. But it's not that much of configuration if you compare it to Axon 2. Now, I'm running this, and right after pressing the button, I know this is not going to work because our object, our account object, is simply not an entity. I don't know what's happening, but I'm pretty sure this is not working. So probably, I mean, the on failure here means it's doing nothing, because our aggregate is far from being an entity. A Hibernate entity. This is a long shot. Let's see what happens. yes, there is no transaction. So we need to configure a transaction on the command bus as well. Return new Spring transaction manager. Platform. So the platform transaction manager is made available by Spring Boot itself. So I'm now just saying that Axon should use this transaction manager, and if it works, I'll be happy, and otherwise we'll just move on. That makes sense because we're providing our own command bus. So it's not configuring the transaction manager because we're supplying our own command bus. There we go. Command executed successfully. Now, of course, if we want to get that working with our own command bus, we need to specify the transaction manager here. So we need to fully configure it, otherwise, of course, it doesn't work. But let's leave it like this. All right, so going back to our slides. Of course, we didn't implement deposit, but this deposit, that's not where the fun part is. So I'm going to leave that to the viewer. Of course, you can send your the results of your assignment to me if you want to get it checked out. So what we've seen, we've built an aggregate, or at least I've built, and maybe you've been co-developing with me. We've built an aggregate. We use the add command handler to annotation to define that the method is a command handler, very similar to Axon 2, and again the event sourcing handler for updating the aggregate state. And we've seen the difference in the apply method. Even though the signature is exactly the same, the apply method is now made available as a static method, and Axon will figure out from which aggregate you're actually calling that method. We've built the test fixtures. Of course, we've implemented those first, being test-driven developers, using the given when then style, just defining the exact behavior that we expect in a specific situation. We're not looking into the black box to see how things work there and provide mocks and stubs and things like that. So it's a very clean way of testing an account from the outside, and of course we checked the outcome, either exceptions or published events. And lastly, but probably the biggest change since Axon 2 is the configuration API, which I've demonstrated in pure Java using the default configurer, or in Spring using the enable Axon auto configuration annotation, which gives me the basic components become available in the Spring context, and the Spring context allows me to define custom components or custom configuration items that I want Axon to pick up. We've looked at the JPA configuration, not so much the JPA event store, although the configuration of that is very similar to the generic JPA repository. Simply by changing the event storage engine and telling the aggregate that I want to use the default event sourcing repository instead of our custom one, it will be the events published will be stored in the JPA event store. And we've also seen how we can customize the command bus if we want to use, for example, the async command bus, or in a real world, it's more likely that you want to use the distributed command bus implementation. So that's it for today. I hope you've really enjoyed the session, and if you have any questions, I hope you've answered the or you've asked your questions to Eliska, and we're going to move to that.